This video covers the process of determining your dataset specifications. I'll talk about conducting background research, determining your data sources, and achieving a representative and balanced corpus. This video is the second video in a series of videos on data collection. If you haven't watched the first, discussing modeling the problem, you may want to go back and watch that video before continuing. Here, we'll be covering stage 2 of a typical data collection pipeline, determining your dataset specifications. This is where you begin to fine-tune your plans for building a dataset and work towards more concrete actions. To determine the specifics of your dataset, you'll need to start by figuring out what's already out there. Good datasets can be really difficult and time-consuming to create, so the last thing you want to do is reinvent the wheel. If in your search you discover an existing dataset that would satisfy your needs, you can avoid creating one entirely. If you don't find any that suit your needs exactly, you can still learn a lot from related datasets to help figure out what exactly your own dataset should look like. Related corpora might be datasets that cover the same task but a different domain, or the same domain but a different task. For example, if your goal is to predict emotions in posts from the UIC subreddit, you might find a Reddit-based sarcasm detection dataset and a Twitter-based emotion detection dataset. Neither of these is exactly what you're looking for, but they can provide valuable clues about what a Reddit-based emotion detection dataset would look like in terms of the size, the label types, and a variety of other characteristics. Particularly when you find datasets that are designed for similar tasks to yours, you should pay attention to the annotation schemata that are used. Chances are, the researchers creating those datasets were following standardized guidelines or otherwise put a lot of their own time into deciding what the best annotation schema would look like. Using a similar schema to theirs for your own dataset will make it easier for others to start using your data if you make it publicly available, and it'll also make it easier to justify why you chose the labels that you did when submitting articles for peer review. You can search for corpora related to your task in a wide range of different places. Some particularly useful repositories are shown here. There's the Linguistic Data Consortium, the European Language Resources Association, the corresponding Linguistic Resources and Evaluation Map, the Google Dataset Search, and the AWS Open Data Registry. You can also check out the proceedings of LREC, a large conference focused on NLP datasets, as well as other conferences within the ACL anthology. Sometimes NLP challenges release new datasets as well. For example, numerous shared tasks are offered by Semivel each year, many of which leverage new datasets, and the Conference on Computational Natural Language Learning often has a shared task featuring a new dataset also. Once you've searched through related corpora and other data sources and settled upon some candidate data sources for your corpus, you should make sure that those sources are representative of the domain you're trying to model. For example, if you're trying to predict emotions in Reddit posts and you've noticed anecdotally that there seems to be a fairly even mix of happy and sad posts in your target data, you may not want to obtain labels for a subset of posts that are almost all angry, since your model would likely learn to overpredict angry labels and underpredict happy and sad labels, rather than appropriately reflecting your target data distribution. A general rule of thumb is to strive for a dataset in which labels are balanced across your different classes, unless your task is such that one class should purposely be more prevalent than the other. You should make sure to carefully document the sources from which you obtained your data, as well as your rationale for selecting the subset of data that you did, both for including in papers that you submit to peer-reviewed venues, as well as to facilitate easy replication or extension by others. If you're planning to make your dataset public, you should also make sure that you have permission to do so. Many potential data sources, such as television scripts, tweets, or books, may be copyrighted or licensed in such a way that prohibits public release, and other data such as medical notes may need to be protected to preserve patient privacy. If you're building your dataset from scratch rather than extending an existing dataset, Common sources for text data include books, news articles, blogs, social media, and human participants. Although the first four sources generally contain text data that existed prior to your annotation task, data from people is typically collected specifically with a given task in mind. It's common to collect data from people when you have some specific need that isn't easily met through the use of secondary data. Perhaps you need spoken or written language data from a particular demographic group, or that conforms to a fixed set of specifications. Collecting data from people typically requires IRB approval, which can be time-consuming, so it's good to get started early rather than leaving it to the last minute and potentially delaying your project. There are two main types of language data that can be collected from people. One is read speech, which is where you write a script or provide a predetermined document of some sort and ask people to read it out loud. This type of data can be useful for psycholinguistic or speech analysis, but it's not particularly useful for many NLP tasks. The other is spontaneous speech or text. This is where you give people a specific prompt or question and then collect their open-ended response. The natural variety in responses makes this type of data collection very useful for NLP applications that seek to distinguish between different groups of people. For example, people may exhibit different linguistic traits based on their cognitive health status, mental health status, or personality type. As mentioned already, regardless of from where you source your data, you should try to ensure that it is both representative and balanced with respect to your end goals. In a representative corpus, the corpus contains samples of all text categories. For example, an emotion detection corpus would have samples of happy, sad, angry, frightened, surprised, and disgusted text. In a balanced corpus, the corpus contains realistic distributions of all text categories. For example, an emotion detection corpus should have approximately equal percentages of happy and sad text, rather than 100 times more sad samples than happy samples, unless for some reason you would realistically assume to have that kind of distribution in your domain. In the example here, this would not be a representative corpus because although the corpus contains samples of the positive class, it doesn't contain any samples of the negative class. This would be representative, but it's not balanced because it doesn't contain a realistic distribution of positive and negative classes. We'd expect to see something much more even. This then would be an example of a representative and balanced corpus. Finally, in determining your dataset specifications, you'll need to decide what size your corpus will be. The general rule of thumb in NLP is that more data is better. Having a larger data set allows you to learn a wider variety of patterns associated with each class. However, more data comes at a price. Collecting annotations can be costly and time-consuming, particularly if you require labels from experts. Even if you have plenty of time and money, it's a good idea to first start out collecting annotations for a small pilot sample of your data to see how your annotation task and guidelines work. It's often the case that you only notice flaws in your task once you start collecting data, and keeping your initial annotation effort to a small pilot sample can help you avoid unnecessarily wasting time and money as you iteratively revise your task. Once you're ready to scale up, you can refer to similar existing corpora to get a sense of what size would be reasonable or desired for the task. For example, if most existing emotion detection datasets contain around 1,000 samples, creating a dataset with only 50 samples would probably not be viewed as a very meaningful contribution, but creating a dataset with 5,000 samples could be very valuable.